Hi, everybody. This is Mr. Folly, and welcome to podcast UG 6.3. Sorry, where we are going to talk about limiting reactants. Geez, I just edited this. You'd think I would have gotten that right. So let's hop right into it. All right, limiting reactant is the reactant that controls the amount of product. The limiting reactant makes the least amount of product. So remember when I talked about the tricycles before? What if I said if I had 9 wheels, how many tricycles can I make? And you go, oh, that's 3 tricycles. But what if I only have 2 frames? 2 frames, oh, that's 2 tricycles. So how many tricycles can I really make if I have 9 wheels and 2 frames? Get back here. I can only make 2 tricycles. So my limiting reactant would be frames. See how that works? So it makes the least amount of product. This is my limiting reactant. Okay. So of course now we're going to chemistry up this bad boy. So I got 20 grams of mercury. Oh, it figures I picked something I don't know the molar mass of. I reacted with 5 grams of O2. Calculate the maximum amount in grams of HGO formed. So now I have to look up, a periodic table. There we go. So, come on. Oh, man. Okay, so I'm going to start with 20 grams of mercury. I'm going to actually get my periodic table. Why don't you get out your periodic table, too? Table. And that way we can have these molar masses handy. So I have 20 grams of mercury react with 5 grams of O2. So I'm going to start with 20 grams here. And I'm going to have 5 grams here. And I want to find out how many grams of HGO form. Okay, so this looks like it's weird because, well, what I'm going to do is I'm going to convert this one into this and this one into this, and then I'm going to pick the smallest. So this is like, oh, let me do a whole bunch of these stoichiometry problems and be done with it. So that's exactly what I'm going to do if it would quit changing slides on me. 20 grams of mercury times dividing bar, grams of mercury, and then I'm going to have 1 mole of mercury. Now what I'm going to do is I'm going to convert this into HGO. So I'm going to look at the periodic table and find out that I grabbed a bad picture of the periodic table from the internet. And let's see if we can find one that actually gives me the molar mass of mercury. Mercury is number 80. And this is what I get for trying to... If you ever think your phone is good for something like this, you're wrong. It's 200.89, I think, grams of mercury in 1 mole. So you go to the periodic table to find that. Times dividing bar. So that cancels grams of mercury. I'm going to now cancel moles of mercury. And again, I'm turning it into mercury oxide. And so I'm going to go into moles of HGO. Moles over moles use coefficients. My coefficients, again, are 2 and 2. Okay. And then I hate you moles of mercury oxide because I want grams of mercury oxide. And 1 mole because I have grams over moles. And mercury is 200.89 plus 16. So that's, I can't believe I put that in my calculator, 216.89. Okay. And now I'm going to put all this in my calculator. 20, starting here, 20 divided by 200.89 times 2 divided by 2 times 216.89. And that's 21.59 grams of HGO. Now, here's my deal. That might be how much I make. Remember how this was? Maybe I can make 3 tricycles, but maybe it's going to be less. So I'm going to do the same thing with oxygen. 5 grams of O2. Hey, 2 grams of O2 going into moles of O2. 1 mole, go to the periodic table, which is 32 grams of O2. Times dividing bar. Then I have moles of O2, and I'm converting it into the exact same thing. Doesn't that seem weird? Why am I converting them both into the same thing? But that's what you do in order to compare them. Moles of O2, and I want to go into moles of HGO. Okay. Coefficient for HCO is 2. Coefficient for oxygen is 1. Times dividing bar. I don't want moles of HGO. I want grams of HGO. So 1 mole is 216.89. Notice how, I know you're doing the same problem twice, but notice how a big chunk of it is exactly the same, right? So it's not quite so bad as it first seemed. Let me erase for that so it's a little less sloppy. Okay. So then I get out my calculator and bust this one out. 5 divided by 32 times 2 times 216.89. And that's not right because I started with a 5 and I couldn't type it in. 5 divided by 32 times 2 times 216.89. And that is 67.8 grams of HGO. Okay, so I need to pick the smaller for theoretical yield. So this is how much my answer is. 21.59 grams of HGO. My limiting reactant is the reactant that made the smaller amount. Therefore, my limiting reactant is Hg. Okay, Hg only made 21.59. This could make 67.8, but I don't have enough mercury to do that. Let's do another. 90 grams of FeCl3 reacts with 52 grams of H2S. FeCl3 plus, go get out of here, H2S will give you Fe2S3 plus HCl. Okay, so I have 90 grams of this guy, and I have 52 grams of this guy. Oh, stop doing that. What is the volume of HCl produced? So I want this in liters. Okay, and what is the limiting reactant? So I'm going to do the same thing. Just convert everything into HCl in liters. 90 grams of FeCl3 times dividing bar. Ooh, I wish it wouldn't do that. Go through moles of FeCl3, cancel out grams of FeCl3. The number I put here, little g stands for grams, and little g stands for go to the periodic table. Fe from the periodic table is 55.85, and then chlorine is 35.45 times 3. So 35.45 times 3 plus 55.85 is 162.2. So now I'm in moles. Oh, I really wish you'd stop doing that. Moles of FeCl3. But I want to go into liters of HCl, so I have to first go into moles of HCl. And that's when I go, moles over moles use coefficients, and then I go poop-poopy-doo. I didn't balance this yet. Okay. So to balance this, I'll make it quicker for you. There we go. So my coefficients are, ooh, that's mean that pops in and out, 2, 3, 1, 6. So FeCl3's coefficient is 2, and HCl's coefficient is 6. Times dividing bar, HU moles of HCl, and we'll go into liters of HCl. 1 mole, remember, is 22.4 liters. And just remind everybody, we do this to cancel that. When I go into moles of FeCl3, I cancel moles of FeCl3. When I'm in moles of HCl, I cancel moles of HCl, so the only unit I have left is liters of HCl. So now let's do the math. 90 divided by 162.2 times 6 divided by 2 times 22.4. So remember, everything on the bottom, divide, divide. Everything on the top, multiply, multiply. And I got 37.3 liters. So maybe that's how much I make, or maybe it's going to be less. So let's look at 52.0 grams of H2S. Oh, I wish that number would stay there. So I'm going to put grams of H2S on the bottom. I'm going to put moles of H2S on top. 1 mole, and little g means go to the periodic table. So sulfur is 32.06, and hydrogen is 1.01 each. So plus 1.01 plus 1.01. So together that is 34.08. Times dividing bar. HU moles of H2S. I want to go into moles of HCl. Moles over moles use coefficients. H2S's coefficient is 3. HCl's coefficient is 6. Times dividing bar. I don't want moles of HCl. I want liters. That's why I put this here and circle it. Liters of HCl. 22.4 liters in 1 mole. Okay. So liters is what I want. Just to make sure I did this right, cancel grams of H2S. Oh my goodness, the whole thing's gone. And you do the math that has just disappeared. I'm sorry, that math has disappeared. But you do that math and you pick the smaller one. I've got a third one on here, so I'm going to go ahead and do that. And hope to the good Lord above my computer stops being all hinky-winky on me. And it'll work. Mixture of 10.325 grams of iron oxide, iron 2 oxide, and 5.734 grams of aluminum metal is placed in a crucible and heated in a high-temperature oven, as expressed by the reaction above. Find the limiting reactant, find the mass of. So I want to find grams of. Don't you do this to me. Oh, it doesn't know I'm in pen. Pen. Grams, and then I have 10.33 grams of iron 2 oxide, and I have 5.73 grams of aluminum. Okay, so I'm going to do 10.33 grams of FeO times dividing bar, grams of FeO, 1 mole of FeO. I'm sorry that the screen just decided to kind of get rid of the other one. I would have liked to have done that math with you. Molar mass of FeO is 55.85 is iron, plus 16 is oxygen. That's 71.85. And then I'm in moles of FeO. And to remember where I want to go, I want grams of Fe. I can't go right into grams of Fe. I have to first go into moles of Fe. My coefficients, moles over moles use coefficients, so I'm using 3 and 3. And then I want to get into grams. 1 mole of Fe is 55.85 grams of Fe. And again, I got this from the periodic table. I'm going to run it through my calculator. 10.33 divided by 71.85 times 3 divided by 3 times 55.85. That's 8.03 grams of Fe. Same thing, but starting with a different number, 5.7. 7.3 grams of aluminum. And then aluminum is 26.98 grams from the periodic table. That's 1 mole of aluminum. Times dividing bar. Now I hate you moles of aluminum. And I'm going to convert it into the same thing, which is grams of iron. First I go into moles of iron. Coefficient for iron is 3. Coefficient for aluminum is 2. And then 1 mole of Fe is 55.85 grams of Fe. And then do the math. 5.73 divided by 26.98 times 3 divided by 2 times 55.85. I get 17.8 grams of Fe. So how much is really made? 8.03 grams of Fe made, because it is the smaller amount. And then my limiting reactant is FeO, because it made less. Remember, my reactants are the ones over here, so it has to be FeO or aluminum. See how this one made the smaller amount? That's why it's FeO. Review, woohoo! Limiting reactant controls the amount of product made. It doesn't need to be in moles. And always go through moles, always go through moles, always go through moles, always go through moles, always go through. See, moles is about. Always go through moles. Toodles.